One of the central principles of statistics is the central limit theorem. So you're already familiar with the normal distribution, but how this applies to data in general is through the central limit theorem. So you will understand that any sample statistics from any distribution will be normally distributed. I illustrated this with the example in the dice simulation in the Excel spreadsheet, where you go from a uniform distribution, the die is equally likely to land on 1 to 6, but if you take the sum of those dies, if you take 5 die, then that sum will be normally distributed. So would the average of 5 dice be normally distributed, and even the standard deviation of 5 dice will be normally distributed. So the central limit theorem states that any sample statistics will be normally distributed if you collect enough samples. So the sum becomes normally distributed, the mean can become normally distributed, the standard deviation becomes normally distributed. Any sample statistics, no matter what the experimental distribution. So that also includes bimodal distributions. For a uniform distribution, the sampling distribution very rapidly becomes a normal distribution. For more severe distributions, like an exponential, where you have some things which have very high numbers and then it rapidly falls away to low numbers, you can need quite a large number of samples before you see a normally distributed set. Now, there's an average of the sample means when you collect multiple samples, and there's also a variability of the sample means. Now, the variability between sample means is called the standard error of the mean, and this is a really important distinction that you have to understand. The difference between the standard error of the mean and the standard deviation, which is within a sample. But we'll come back to a more detailed discussion of that when we look at confidence intervals.